Okay, seems fine. Good evening, everyone. I forgot to unmute myself, sorry. Okay. No, everything seems fine. My mouse is glitching. Okay, so last time that was a fun rage end of stream because I smacked my table and it basically killed all of my USB connectors. So I had to finish because I lost first my keyboard, then my audio, then my camera. So we will be doing the previous Wasp Hunter. Why there's two? So this wasn't finished. I wrote basically the whole program, but it's a poor bot drown, unfortunately. Because of this. We will remove this and try like that. Should work. Okay, now again he's doing some weird stuff. Okay, one down. He's trying to shoot it again. Oh, how long this will be dying? Ah, finally. Come on. Find next target. Ah, I forgot again. I can change the speed. Come on, come on, come on. Ah, you can. Ow. Come on. Yeah, finally. Come on, next one. Yes. Don't drown, please. Yes. Well done. Mission accomplished, finally. Get better at shooting down the wasps. Yes, I should do this. Bring down the flying wasp in a more efficient way. Here is again the program of the previous exercise. It should down all the wasps after many, many unsuccessful attempts. While radar k equal null. Radar again, turn. Jet k. Turn fire. Okay, the many failures are due to the fact that the wasp is already gone before bullets can reach it. Finally, they address this problem. The only way to improve the program consists in setting the power of the two motors and of the jet in such a way that the bot follows the movement of the target during the burst. But how you know where it will go? Because you can start moving before the burst and you can change the move when you shoot, and wasp can just change trajectory when you right before you shoot. It will be also useless. Just before the shoot, the program adjusts a last time the direction with turn direction item position. In order to follow the wasp during the burst, you have to remember the angle of the last rotation. If the angle was positive, rotation to the left, the bot must continue to turn left during the burst. If the angle was negative, the bot must continue to turn right. In order to remember the angle of the last rotation, we need a variable that can contain just one number. If we choose to call it angle, we must define the variable. With the following line at the beginning of the program followed, that's not actually true, but okay. The variable type float is a variable type that can contain any number, example whole numbers or real numbers. Any number, it's more than a whole and real numbers. Please refer to the text about variable types if you want to know more about the different types of variables and what they can contain. Just before the instruction fire 1, instead of writing turn direction, we will put the rotation angle into variable angle. Then we will perform the rotation and we set the power of motors of the bot to continue the movement. Okay, so basically they won't turn and burst at the same time. Then we perform the rotation and we set the power of the motor so the boat continues the movement. The instruction else determines that instruction the programmer should execute if the condition stated in the if instruction is false. Then we must set the power of the jet so that the boat follows the wasp also in the vertical direction. Jet 0 if position greater than target position, we will go down, other way go up. As you will see, the program is much more efficient than previous one. Can I grab my previous program? Let me go back here. I will go here and save it as wasp1. Now I will go to the next mission and we will modify my code. Turn, so Yeah, we will create float here. Just because if you will create it in the while loops, it will be recreated each time, and that will be stupid. Turn and if angle greater than 0, motor. Which direction? Which? If angle positive, rotation to the left. So motor minus half FL and half 5. Else motor should be like that. 0 errors. Let's try. The hell I doing? Oh, okay, flying. But I forgot to add the instruction to stop this. Illegal object. Start. Fire. After fire, we will stop the motors. Okay. Come on, they all basically the same place was. Game doesn't work if I tab out. Okay. Troll, are you okay? Why get the incorrect name? Illegal object. What the hell happening? Apparently forgot. Whoop. So the program. So it's failed here because it entered here when it was not null, and then Wasp died. No. Okay. Yay. It's kinda more efficient, but still far from effective. What are you doing? This wasp is died already. Come on, find a new target. And don't drown, please. Why are you shooting in a different direction? Nope, nope, nope. Should be K. Let me create one motor minus 0.5. Why are you not turning? Now it's turning. So this is to the right. Can I breakpoint here? No. Execute. Stop. Message angle. It turns to the right even if the angle is 0. Zero. He turned to the right. Same thing. Come on. Yeah. But it still was able to kill it. And it failed. Why Kick doesn't have option to make chat? Yeah. Follower only is on. So this bot followed me, waited 5 minutes and spammed. Too much effort, you know? This I don't need. This come here. Delta. Just I need to make an altitude. But it will again check altitude to the ground, I think, not to the water. Okay. Fast forward. It takes more than 10 seconds for the wasp to die. And I don't think I can check if it's in the process of dying. No, don't can go down. Why? He tried to attack it when it was dead in the water. That's bad. So still my bot's afraid of water. Come on. Yeah, finally. One way or another I passed this mission. So all stuff is open, just it's noted what I passed, what I didn't. Move the bot along a given path. Okay. F1, thank you. Oh, we got a... how it's called? Track with stuff. Program the robot in such a way that it arrives on the finishing pad after having passed by the 3 blue crosses. Okay, procedure. Take the power cell and put it on the rear of the bot. Walk around on reconnaissance to understand what the bus must do. Program the bot to do so. You must select it. Sorry, there was a comma. point. Program the bot. To do so, you must select it and then click on the braces button. Okay, you will get into the program editor. It's as usual. Once you finished, clicks run. Okay. The paths are at a distance of 20 meters from each other. Instruction: move 20, turn 90, turn minus 90. So right is a minus. Okay, why they decided to do like that, I don't know. Usually clockwise, which is, if you look from the top, is usually is positive. The frame of the program consists in external void object move bot. Write the necessary instruction here. For now, you must not change the frame of the program. Okay, so they will eventually tell me what this means and how I can change it. Just insert the instruction. You need to move the bot around between the braces. Okay, attention, be very careful about uppercase and lowercase letters. Every instruction must be terminated with semicolon. Helpful trick: when you write the program, you can watch the scene by clicking on the button reduce. And by moving the mouse to the edge of the window to turn the camera. You mean I can zoom out, zoom in, and rotate? So to place, I need to make it manually. Yep, because it's not a grabber, no power cell. Oh, no, it's an answer. I don't need this. Oh, I can't fly it, unfortunately. So whoop. 20 meters, they say. So move 20, turn left, move 20, turn right, move 20, turn right. So move, turn, move, turn, move, turn. And move. So 1, 2, 3, 4 moves. 1 turn, 2 turn, 3 turn. Okay. Okay, we will not turn. To the left it's 90. Then move another 20. Then turn to the right. Move 20. Turn again to the right and move 20. That's more exercise for my memory, if I remember the course, but I forgot the crucial part is to place the battery. Here you go. We voila. We are accomplished mission. Follow with variables. Use variables in order to store the parameter of the path. Yeah, I thought about it. So it's the same course. Yep. This exercise is very similar to the previous one. The bot must move exactly in the same way, but when writing the program, you must use a new concept that is extremely important in programming: variables. There's got a strange, order of exercises. This must be first exercises before flying and stuff. You have to explain moving and variables. We saw that all the paths are at distance from each other 20 meters and all rotation performed consists of 90 degrees angle. Instead of rewriting the same value over and over again, we can store them in a variable. Okay. Variable composed of 3 elements: the name, the type, there's no type, but okay, and the content. Use the name to refer to a variable. For example, instead of writing move 20, use move distance. Distance is the name of the variable. You can choose almost any name of a variable. For example, this dir p2ax, nothing to grab, etc. The type of a variable determines what kind of information the variable can contain. According to the type, a variable can contain a whole number, a real number, a character string, the coordinates of a point, etc. Here's a list of the most common variable types. Okay, int for a whole number, 12 minus 500 for real, for character, point for the coordinates, and the object for information about an object. The content of a variable can be a number, a string, coordinates, etc. according to the type of the variable. The content of a variable can change many times during the execution of a program. Before you can use a variable, you have to declare it. For example, before you can use the two variables dist and dir, you must declare them with the following lines. Flow dist, flow dir. Dir, it's a direction, not a directory. Usually dir, it's a directory. Now you can use the two variables to put the value 20 into dist and 90 into dir. It's more of a angle, not a direction. Direction will be with a sign, because you can 90 to the right, 90 to the left. It's two different directions. It's not even a direction of a turn. It's amount. Now you can move and turn to both of the instruction move and turn. You can also use the whole mathematical expression instead of just a variable, but it's not a good idea, just in case. Performing like simple math in args is kinda tempting, but who will read this, they will don't understand why you added exactly 100. What the hell 100 is meaning? That's a magic number. Magic numbers is bad. The latter instruction will be needed to turn the boat right. Now rewrite the program of the previous exercise, but use variables. Do you have an enums just by an azar? Class public private static synchronize. Okay. Apparently no. Okay. Let's make new. So we got int distance 20 int no, it will be float because angle will be can be not whole. Next, they don't have a enums, but we can do. So turn left equal 1. This will be direction left and direction right -1. So we can move distance because we are moving only forward direction back will be not required. Then we are turning direction left by angle. And then move again. Not a dust, dist. Then we're turning direction right by the angle. Then move 20. Oh no, sorry, dist. Then we will just need to repeat this. And voila, it should work. Yep, I didn't mess up. What it should. Okay, massacre. Use a loop in order to destroy 6 targets. Oh my. Oh my. What the hell is happening here? I think they will explain me how to like move, stop, shoot, move, stop, shoot, move, stop, shoot. But there's other solution. No. I didn't see anything. Destroys a 6 target with a program using a loop. The bot must move 5 meters forward to get from one target to the next. The program must execute the following scheme. Repeat 6 times. Move 5 meters forward. Turn 90 degrees left. Shoot. Turn 90 degrees right. Okay, I will explain it later. The instruction 4, ask for 3 expressions, but they are optional, just in case. Initialize the counting variable, the end condition, the counting expression. Here is the loop once it is integrated into the program frame. Okay. So yeah, this is a classic for loop. So you're starting from 0 and less than 6. And you are incrementing. But you can do other way. You can start from the 6 and decrement and go until it's 0. I think most of the time, and if you will even write it like that, the assembler, compiler, when it will convert it to machine code, will invert it into the decrement because it's easier for computer. Attention, the line 4 must not be followed by a semicolon. Yeah, because this is the whole expression. And also here, it not requires semicolon. Explanation of the instruction 4. Integer I equals 0. The variable is set to 0 before the beginning of the loop. E less than 6. The loop will be executed as long as it's smaller than 6. At the end of the loop, add 1 to the variable. So they don't have an increment and decrement operators. Okay. Use braces in order to create a block. All the instructions that must be executed in the for loop are held together by a block. The whole program itself is made up of a block. Yep. Never change these characters, just add the instruction of the program between the braces. You can fit several blocks onto each other. For example, the for block is fitted into the block of the whole program. In order to improve readability, the editor lines up the braces belonging to the different block. Remember, the instruction used to move forward is move, to turn, positive turns left. The instruction used to fire the cannon is fire 1, a 1 second burst allowed to destroy all 6 targets. Each of targets, not all of them, I suppose. So, what they want? So we will make float and int distance equal 5 float why I can't copy from my previous would be nice. Int dir right left, okay. 1 int dir right -1. Then 4 int e equals 6, e greater than 0, e equal e -1. Just like normal languages get this. So this is equivalent to decrementing basically, and also like that. It means the same like this, but not in this language. So move distance, turn direction left by angle, then shoot, fire. Okay, we will make it like that, but it's also can be moved here. Then we turn direction right by the angle and start over. Seems fine. Okay, go. So they're turning the whole thing. But can I turn only the cannon? No? Too bad. I think turn will not work as I wanted. Okay, exchange posts. Collect valuable information from information exchange posts. Never used it in this game yet. Oh my god. That's mines. So this... Oh, I see what they are doing. This number is like direction, it's angle. A number, I think it's order. Yeah, that's the second one. Again, but direction 45 here and 135 here, and then minus 45 here. Interesting. Several information exchange posts stand in the middle of a minefield. When the bot is close enough to an exchange post, it can read the information that it contains. Every exchange post contains the angle of the rotation that must be performed in order to reach the next exchange post without touching a mine. The exchange posts are distant 20 meters from each other. Repeat 5 times. Move 20 forwards. Read the direction of the next information. Exchange posts execute the necessary rotation. How do I read? Receive. Okay. In order to repeat the steps above, use the for loop. Okay. Move forward with the instruction move 20. Use the instruction receive and direction in order to read the information. Contain the exchange post. This is of course possible only when the bot is close enough to the exchange post. You will need a variable to contain the value. Retrieve the exchange post. Let us call it dir. You must declare it with the following line. Yeah, now it's more like a direction because it will contain the sign. Then retrieve the rotation angle from the exchange point, should put it into the variable. Then turn. Remark, you can click on an information exchange post in order to read what information it contains. In the exercise, every exchange post contains only one value called direction, but it can contain up to 10 different values, as you will see in some of the following exercises. Nice. Interesting concept. So, float dir equal 0. Int distance equal 20. For integer I equal 5. 5. I greater than 0. I equal I minus 1. Come on. Next. We need to move distance. Then we are receiving next direction. Name. Direction. I read instruction somewhat. Okay, so yeah, direction. I need to grab the name from there. Okay. And we can turn to deer. Should be fine. Okay. And last two. Yay. I made it. We are smart. Exchange post 2. Collect more valuable information. Let's read. In this exercise, information exchange post along the way contains the direction of the next post and the distance. Yeah, that's what I expected. And you do not know how many exchange posts you must get in touch with before arriving at your goal. Repeat forever. Retrieve the direction from the exchange post. Retrieve the distance from exchange post. If no information could be retrieved, stop the program. Execute rotation. Move forward to the next post. In order to repeat, always use while true. The instructions between the braces will be repeated over and over or until a break instruction is executed. This time you need two variables, one for the rotation angle and one for the distance, for example deer and lamb. It's strange they named it length instead of distance. A variable of type float can take a special value, called none, not a number. Yeah, not a number. This value means that the variable contains not a number. And there is no exchange post nearby, either because the bot has reached the goal or because it took the wrong way. The two variables, deer and lamb, contains this value. You can test this with the instruction if and stop the program if necessary with the instruction break. Okay, at least they explained how to break out of an infinite loop. If the information retrieval from the exchange post has been performed successfully, execute the rotation and move forward. You can click on the post. Okay. So, we got right here. Number 1, direction 0, length 50. So we first do stuff, then move. So variables, we got integer len call 0, none. Interesting, by default it contains 0 or none. Float deer. Next we need len receive length deer receive direction, I suppose. If len and or we will break like that, or deer equal none, we will break. Or we will move first turn direction and then move the land. Okay. Nice track we got. Okay, let's move fast forward. Oh, how many there is. Okay, we're almost done. And there it is. Voila. Labyrinth. Teach your bot how to find its way out of the labyrinth. Wow. Interesting. Can we scan for the walls? Yeah, of the barrier apparently. Program the bot so that it will find its way without hitting the walls of the labyrinth. We suppose that you do not know the configuration of the labyrinth, but there is no bifurcations, okay, and no dead ends. The labyrinth is made of squares measuring 5 meters each. Distraction radar. Distraction radar barrier 04505 will find any barrier on the front of the radar that is closer than 5 meters. Let us take a closer look at the 5 parameters. So this is the category of the object which we are searching for. Direction. Direction means straightforward. 45. Open angle in degrees. With opening angle of 45, the barrier is situated between, so like that, in front of me. 22.5 to the left and to the right. This is 90. 45 is smaller. Minimum detection distance 0. Very close. 5 detection range. Take another example. This radar command will direct the radar 90 degrees to the left in order to test if the way to the left is free. So it's usual like stick to the one wall and follow it. And you will eventually find the exit of any labyrinth. Because you will be just hacking the wall and there is no other way either than find the exit. It will be slow, but 100% sure. Of course, if there is no traps where you can die. General principle. The program must only take care of one square portion of the labyrinth. You will have to execute it several times in order to arrive to the finishing path. If there is nothing in front, move forward. If there is nothing on the left side, turn left, move forward. If there is nothing on the right side, turn right, move forward. First of all, declare the three variables of type object that we call front, left, and right. Variables of this type can contain the description of any object. For example, of a barrier found by the radar. Okay, object front, left, right. Look for the barrier in all three directions. and put the result of the reader instruction into the free variables defining at point 1. If the reader finds nothing, the variable will contain the value null. Okay. Let's test if the way is free in front of the bot with the instruction if. If the test is true, the instruction in braces will be executed. Otherwise, the execution will resume. After the closing brace, the instruction return leaves the program. The job is done. Test if it's possible to turn left. If so, turn left with the instruction turn and move 5 meters forward. Test if it is possible to turn right. The instruction if must never be followed by a semicolon. Okay. Oh my. So, objects. Front, left, right. We got 3 direction of turning also. So left, right, and front. Oh, front. Can I make an object array? How do I make arrays? There's no arrays. No arrays. Integer A5. Okay. Object. Directions. So like that. Yeah. We don't have dictionaries. Then we need to scan. Like that. Let's copy paste it. I can't copy paste. Are you freaking serious? So direction 0 will be to the left. Reader barrier out to air, sorry. Barrier maybe I copied the wrong. I think I need to copy like that. Paste. Why I can't copy? Copy. case. Bastards. So, left 9045 05. This will be a straight. This will be to the right. Yep. They all different only here. Oh, we need a float angle 90. How I can work with arrays here? Do you have any methods? No. Okay, I think it will be useless in this case. Okay, let's change it back. Front, left, right. Right, not fight. Just I wanted to use the indexes of our like items in the array as a multiplier for the angle, but I can't find them. There is no find method apparently. Okay, so while true, apparently it will be all inside the one big while loop. Switch. We can't use switch in this case if front not equal null. Can I make a function here, void move? Distance int distance, so it will be move. Turn and move. So float angle integer, so we will turn angle and move distance. Can I even do like that? Like 0, 0, just for test. Yeah. Wait, turn left. Then I don't need this. Okay. Float angle. Turn right. So if in front of us, we just need to move distance. Integer dist 5. If else left not equal null, we need to turn left to the angle and move distance. And if else right not equal null, turn right to the angle and then move distance. Compile, break. Oh, fun. Else if that's semicolon, classic, and I pressed cancel. At least it's saved. Okay. So turn and move I don't need. And if all of them false, we break. Yep. Nope. I checked for not null. I need to check the opposite direction. Equal null. That's better. Oh. Voila. We are done. Labyrinth 2 teach you bot to do the same job in a more autonomous way. So there is not each is 5 meters. Still, let me grab my previous one. Labyrinth. F1 exercise. This exercise is very similar to the previous one. This time the bot should find its way alone from the start to the goal. You will have to execute the program only once. I did it the previous time the same. The labyrinth is not exactly the same, but this should be of no importance as the program adapts to what it sees. Yes. Use an infinite while loop in order to execute the previous program several times. Oh, so I supposed to click on each turn before. Inside this while loop, replace the return instruction by continue instruction. Return would quit the program, which is not what we want here. Continue will just resume the execution at the beginning of while loop. That's one way to do this, but else if also works. Just exiting from the function each time is kinda expensive. Wait a minute, I want to check their solution for previous labyrinths. So they actually did like step by step. So my program from this level should complete this labyrinth without modifications. Because it's searching by itself. Let's see. So yeah, my program works fine even here. I call it a success. After all, I'm not so bad at programming. The gold digger. Instruct your bot to search a zone for subsoil resources. Subsoil. Okay, it's a sniffer. Search the whole zone inside the barrier with the sniffer bot for adequate location for a derrick. When the bot sounds the subsoil and discovers an adequate location for a derrick, it will mark it with a red cross. The zone inside the barrier is a square of 25 meters. The most efficient way to check every 5 meters. One way to achieve this is to feed 2 for loops, one into another. For less than 6 and this less than 5. Okay. Sound the subsoil, move 5 meters forward. Sound quarter turn left, move 5 meters forward. Turn left and turn right, and turn left and turn right. This program works well only at the beginning. After the first line, the bot turns correctly left and sounds the second line, but after the second line, it must turn right. You will have noticed that if Y is even, the bot must turn left, and if Y is odd, the bot must turn right. Yeah, that's exactly what I was thinking about. That it just should change -1 to 1 each right time. The expression y%2 returns the rest of the division of y by 2. It's called modulo. For example, if y equals 3, the expression returns 1. The test if can be followed by an else. If the test is true, the first block will be executed, otherwise the second block will be executed. Step to you to finish the program. Use the instruction sniff to sound the subsoil and move to turn to move the bot. They don't have a bitwise operators. Like there was a hacky way to find if the number is even or odd, because division is also complicated for computers. There is a bitwise operator right, which moves number one bit to the right, and you will get the right bit which was pushed out. So if you will look at the bit representation of, for example, 2, it's 0, 1. And for 3, it's 1, 1. And if you will push to the right the last bit, you will get 1, basically like that. And you will get, as a result, 0. Here you will get also 1, but as a result 1. And like that, with much cheaper operation for the computer, you can check if it's an even or odd number. Because every odd number got 1 at the end. Like 5, it's 0, 1, 0. And you will get 0, 1, 0. And at the end will be 0. And you will get 1. And that's working for every odd number. And basically this shift to the right is equivalent to dividing by 2, because every bit is basically power of 2. Moving number one way or another, it's either multiplication by 2 or dividing by 2. That's why, like, if you get 4 bytes, it's a 0, you will make like that, it's 2, like this, it's a 4, this, it's 8. So moving bit to the left, you're basically multiplying by 2. That's actually why, if I remember correctly, why everything basically is divisible by 2. Specifically RAM sizes, like we get 64, 128, 256, 520. This is basically multiplying by 2. Because adding 1 bit to the memory gives double the capacity. So let's go back to the thing. So we need to go, how we go forward first. So for integer len equal 5, width equal also 5. For width so it's find here, we can get like that, greater than 0. Hope I will not mess this up. So width adds this, and second is len greater than 0. Just I don't remember why there's a difference in 1. So here we got 6, here we got 5. 1, 2, 3, 4, 5. But 1, 2, 3, 4, 5. Why 6? I don't remember why it's happening. Why there's a 1 more. Because we need to move 1 tile less to this because we're already on the first one. So what the fun is this? You can just see it visually. I need sound the subsoil, sniff, move, turn. Sniff, then move distance. And each time here we need to turn integer angle. But we need a direction. And angle is a float. Direction will be equal. They don't have a ternary operator. That's why they're using if else, because in like other languages you can like with modular it's equal like 0 if then if this true it will use this, if it's false it will be this, and you can just assign it. But they have a ternary operator. Oh, they got binary operations also. Wait a minute. And they got this addition and subtraction. They actually get, and there's ternary operator. Okay, they got bitwise. I need to read docs apparently. Just in case any problems with the order of operation, we will add a lot of braces. Let's see. Okay, 2, 3, 4. And he glitched. Let me check my program where I messed up. Can I make you smaller? Not really helpful. So this is okay. I'm getting here, sniff. Move. Sniff. It's greater than 0. Move. Yeah, too many moves apparently. Sniff. Move. Ln is 1. So we will get this. We will get this. We got 0. And apparently we will not go inside. Yeah. We will not sniff here. The first problem. So it changes to equal. Let's try. What the fun are you doing? Not equal 0, sorry. One. Again. Okay, sniff. Program finished. Okay, I thought it will make kind of breakpoint, but no. Let me check this logic. And the first run, width is 5. We need to turn left. Okay, let's debug it. Okay, move. Not equal 0. Okay, now. Ah, I forgot I don't restore these values. I need to change this to the different volume. That's why he's turning on the place, because this for loop doesn't work the next time. Interesting why it's -1. Ah, because it's a false. It's odd. Okay, so this will be usually it's not a good idea. With I don't remember. So we will make e equal if, and if this and -1, this will be g equal len g0 g minus equal 1 should work. A variable not declared as integer and integer. Hey, where are you going? Whoops. We'll just go around the barrier. Well done, mission accomplished. They didn't even bother to place any pink in the middle, apparently. That's not a correct solution, people. So we need to turn left, then move 1 and turn again. And we didn't check actually the last tile. He starts first. 1, 2, move. 1, 2, 3, 4, 5. It should be. Ouch. Oh, nope. So we sniff and then move. We should make 5 sniffs and 5 moves. He made. I think I forgot to change this. I want to solve it properly. The hell? Why are you turning here? I is 5. First time it's false. We're getting here. Then it should be 4. I should get here. The hell? Second sniff. Okay. Turn to the left. Move. Turn to the left again. This again 5. No. E is 4. So it's supposed to be right. Sniff. Move. One. Turn. Angle. Why it's 1? What the? Where is bitwise operators? Returns 1. They return not the bit itself, they return the value. Yeah, check one thing. How many sniffs it does like that? 1, 2, 3, 4, 5. But there's a 6th place. 1, 2, 3, 4, 5, 6. What? 1, 2, 3, 4, 5, 6. Because thing is 6 by 6, not 5 by 5. They got 5 here, squares. But here actually 6 squares. 1, 2, 3, 4, 5, and 6. First one to the left. This one to right. And now it's trying to move. Stop. But it makes the last sniff. So we need to add another sniff here before the turning. Or it will just not sniff this square. Okay, so this I first is 5. So I switched it wrong. Oh. Now it's making something. Well done, mission accomplished. I even I didn't even make a half a freaking field. But it will work anyway, okay. Remote control a robot using an information exchange pod, so it will transport uranium ore. Interesting. Okay, remote control a robot using an information exchange post, so to transport uranium ore. The main actors of this exercise are: a sniffer can carry anything. An information exchange post that receives information from a sender and then transmits it to a receiver. A grabber, which waits for orders from the exchange post. You have no way control this robot directly. An information exchange post source name value couples. It's basically a dictionary. To control the slave robot, we use just one couple. Name order, valuer, order number. What? The slaves, maybe slave robot. They got a typo here. Robot understands the following orders. First grab, then drop, then move -10. To instruct the slave to move forward 10 meters, all you have to do is send order free 10. So they got like array of commands with indexes. Order 3, move 10. So 100 it's a power. Yep, power. Power of the transmitter, which corresponds to the maximum distance to where information can be sent. Default is 10 meters. So it's 100 meters. Or it's power in percentage, and like 100 at 100% of 10 meters. And 10 will be equal to 1 meter actually. Instruction unclear. You know what happened later. After the send instruction, we wait for 5 seconds to be sure the move is done. Remark, there is a better way for waiting. The order has been executed, but we will see this later in exercise remote control 2. To finish the exercise, you must take the uranium ore, move forward by 10 meters, drop the uranium ore, move backwards by 10 meters. It's up to you to write the program. Okay. So I can't do anything with him. We got exchange post. Sniffer. Take uranium, move forward, drop the uranium ore. So sniffer is just for sending the message. I don't need move and anything. So send name value power. Command. No, order. One. Can we duplicate this? So we need 4. Grab and drop. It's a second drop. No. What the hell? Order. It's all Are we good? Nope. Oh, we're back. Internet for some reason glitched. Are we connected everywhere? Okay, Twitch is fine. YouTube. YouTube, are you okay? Okay. We kick. Kick is thinking, okay. Trova. Are we back? Kick for some reason is stuck. Trovo is fine and camera is fine. Oh, kick, hello. And we're back. Okay. I don't know if it's my internet glitched or servers. I think mine. Can I quickly check? Это... Yep, disconnected. My internet disconnected. Okay. So we are back to this. Move is the third command. And drop actually is second. So grab, drop, move back. Four? 1, 2, 3, 4. Okay. Compile. Oh, I forgot one thing. I need to wait. Wait signal. Wait 5. Okay. And we are done. Now back. Mission accomplished. Remote control 2 is only here. Okay, let's make a dragster. Program a progressive deceleration in order to avoid the mines right behind the goal. Huh. Reach the finishing pad 25 meters in front of you as fast as possible. Using the instruct motor, you will have to slow down progressively at the end of the move, otherwise the boat will get blown up on the mines. You could very well write no more than move 25. This would work perfectly well. However, the aim of this exercise is to learn how to use the instruction motor. This instruction asks for two values, the speed of the left hand motor and the right hand motor. The value must be ranged between -1 and 1, -1 full throttle backwards, 0 stop, 1 full throttle forward. What's happened here? Okay. For example, motor 0.5 will move the water forward with half speed until new instructions are given to the motor. With instruction motor 0.5.6, the boat will move forward until with half speed, turning at the same time slightly to the left. The right hand motor moves a little faster than the left hand motor. In order to move forward for exactly 25 meters and not more, you must move full speed during the first 23 meters and reduce the speed of the motor progressively during the last 2 meters. The variable position will gives you at any moment the current position of the boat. And the instruction distance returns the distance between 2 points. The best way to know where you are consists in saving the current position before the start into variable, for example, a variable called start. Then you can calculate the distance between the starting position and your current position with distance position start. Declare the variable point start float length. Save the start position. You can make it at the start of the program with a declaration. Then start full throttle. Perform while infinite loop, checking for the distance. If again magic numbers, but we basically right now know what it means. 25 it's a whole distance, and 2 meters and where you need to start to decelerate. Motor less than before. Nice. As long as the distance between the start and the current position is smaller than 23 meters, the instruction. Oh, blob. The instruction in braces after the if instruction will not be executed. So then the motors keep their maximum speed as they were told by the motor 1.1 instruction. In order to slow down progressively, the speed of the motors must be proportional to the remaining distance. Okay, 2 meters maximum, meter and a half, 0.75. I just divide 2 by the rest by 2. You can use the following expression: 25 ln by 2. Yep. In order to calculate the value of the speed instruction that must be given to the motors. Len is a distance, okay. It is now up to you to put everything together and test the program. Remark, you can use value greater than 1 for the instruction motor, but the bot will not move any faster. So integer length is 25. Integer stop distance is 2 meters. Yep. Yeah, 2 meters. While true. Wait like half a second. Oh no, I will not wait. So if integer distance call len distance equal distance right point start call location position we will get position starting position. Yep. If distance less than stop distance, we will start accelerate. Motor 1 1, then motor will be we will create a power here. And the power will be calculated as stop distance distance. Stop distance. Distance divided by stop distance. Like that. Semicolon, sorry. Type declaration missing. I forgot brackets for the while. Am I correct with this? No, we are not moving. That's why I assigned the distance to the length. Oh no, wait a minute. Distance will be assigned here. Distance greater. Oh no, wait a fuck. Distance less than stop distance. Or equal. Just why motor 1 doesn't work. Power is 1. Distance is undefined. I need to check distance not between start and position. Start and end. They use it like that. They do it in a different way. They count how far I am from the star. But still, distance is undefined for some reason. Start is okay. And position is also okay. But why distance is... I need to step. So distance is 0. And because I messed up, we are getting inside this if immediately. So yeah. Distance from the start. That's why proper naming from start. No, everything fine. Okay, let be like that. So if distance len minus distance less or equal nope. Well done, mission accomplished. Sorry, mission failed. Can you freaking made up your mind? Can I make a breakpoint here? Debugger? No. Okay, message. Will it be called? Stop. Okay. So we are getting inside this loop at least. length. Let's see what's happening with the power. $11. Distance. Because I need not the distance, but this. Or yeah, because this is constantly growing. Then this is became smaller. Rest. Should be fine. Yep. Why it was printing 111? I don't know. Let me see. It's no power. I need to print it here. Because message can't print float. And actually power must be float. What the hell? Or it will go from 1 to 0 immediately. Strange, it still prints 1. Let me check what they got. So it's a rest, so distance between like how far and how long. By 2. Basically it's a stop distance. Yeah, they got less lines, but it's less readable. Okay. Voila. Use the radar to find lots of stupid blue crosses. Press F1, okay. Let the boat find all the blue crosses on the ground. As soon as the boat passes over one of the crosses, it will disappear. Here is a general principle that you will apply. Repeat forever. Look for a cross. If there is none, stop the program. Calculate the direction of the cross. Set the speed of the motors in such a way that they will find their way to the cross. So it's not just go to. Use the while loop in order to repeat several instructions over and over. Okay. Instruction radar will detect the blue crosses and put their description into a variable, for example, spot. In this case, radar needs only one parameter, example category of the object that it must look for. Once all the crosses have been found, radar will return the value null. You will have to test this case and react accordingly with the instruction if spot equal null, no more, motor 0, break. The instruction break will stop the infinite loop while true. Use the instruction direction to calculate the angle of the rotation the bot must perform in order to turn towards the blue cross. So the coordinates of the object are given by spot position. The following line will put the angle of the necessary rotation into the variable dir. Okay, direction, spot position. The value of the angle is positive if the blue cross is on your left, negative is on your right. If the cross to be reached is in your left hand, you must set the left hand motor to full speed and set the right hand motor to full and left to the lower speed according to the angle. Oh my fun! So I can just turn. Direction 0, speed 1, 45, half, 90, 0. Left, right. The graphic below shows the speed of the left hand and right hand motors as set by the instruction motor according to the angle. So 1, 1, minus 1, minus 1. But how do I stop the motor? I need to check direction constantly, and when it's 0, I will change the motor behavior. If the cross is straight ahead, the angle is 0 degrees, the motors will get the speed 1 and 1, which means full speed ahead. If the cross is behind, the right motor will be set to minus 1. It will turn around. You can use the expression 1 plus direction by 90 in order to calculate the necessary speed of the motors. Use the same principle if the angle has got a positive value ranging between 0 and 180 degrees. It is up to you to work out the exact construction. Oh my god. At the beginning of the program, you must still declare all variables. Spot is type of object, whereas dir is type of float. Oh my. So object is the spot. Float is angle. No, not angle. Now it's actually a direction. While spot radar way point not equal null, and if it's null we will set motor 0, 0. Okay. Where is your freaking stuff? Oh, so if direction less than 0, we need to direction spot position. Direction position spot No, it's calculated from my position, so I don't need this. Okay, if direction less than 0, we are getting this formula. 1 direction 90. It doesn't copy direction by 90. This else same but in the different direction. Let's try. Woohoo! Eventually he will find every cross, but it will be a really interesting exercise for it. It turns only to the right. Direction. So with 0, we both go 1 1. If direction equals 0, motor, oh my phone, motor 1 1, else if written. So basically else. Direction positive goes to the left. Yep. So we will turn to the left, so more right. And this should be inversed, no? Why they made it like that? If direction, less than 0, it's to the right. So left works to the full throttle. This is dependent. Why are you turning right? Yeah. Come on. Let's try. Position, direction. Where is the direction? Direction is 90. It should turn left. So the right motor will be full throttle, and left will be 2. Which will also make 1-1. Interesting. But it turns to the right. Let me make float. Where? For power. Maybe because I need minus. Let me think a little bit, maybe. How they made this formula? So, for example, direction minus 90. This will give us minus 1, 1 minus 1, 0. So we'll get this. To get opposite, we got 90. This should be here, first of all, because right will be always full throttle. Then we got... so this must be minus, because this will be always positive. And this should be subtracting. Ouch. So let's grab you. And grab you. That's why it was turning right all the time. Although no, it should be 1-1 always. So it should go straight. It can't accept values more than 1, but no. Okay, he's doing something at least. Which looks like a correct behavior. It's not the optimal trajectory, but it makes work done. Okay, crazy bot. Use the radar to put some order into a big mess. Left behind by a crazy bot, okay. What is he doing? So he is placing waypoints, and I have to go like by them. In this exercise, a crazy bot places many blue crosses on the ground. In order to find them, you can reuse the program written in the previous exercise. This can show you the flexibility of such a program. It adapts to whatever environment it encounters. Do not wait too long, because the crazy bot gets down to work immediately. Fortunately, as long as you end the program editor, the game will pause. Yeah, but I need to get my previous then. Ow. Let's save you. Find process. Now, crazy bot, come here. And let's. Now we can find two at one. He placed them too close. He wasn't able to move from it. We tried to find it already. And they stuck. Now, who will win? And I won because I broke his go-to command. Come on, you can do it. Ah, you bastard. That's what happened when unstoppable object finds unstoppable object. Yeah, unmovable, sorry. Come on, you almost moved him out of your way. Because he's broken, he will not place any new crosses. Aha! We won! Patient hunter. Be patient enough to not to waste your ammunition. Ooh. Okay, you must find a way to destroy the 4 moving target bots without wasting one shot. Notice that after every move, the target will stay motionless during 1 second. Detect a target with the instruction radar. Turn towards the target with turn direction. After the rotation, check if the target did not move. If it did not, wait 0.2 seconds, we wait. Recheck if the target did not move. If it did not, shoot with fire 2 and wait 2 seconds for the target to be hit by the bullets and destroyed. There are, of course, other ways to achieve the goal. I just spray all around. Don't give a damn. In order to increase the efficiency of your shots, aim a little downward with aim -3. Oh, so they are moving. Oh, and pretty much chaos. Oops. 1, 2. 1, 2. Turns. Can I just wait until they waste their batteries? So, detect a target. Object. Target. While. Target. Equal. Radar. Target bot. Not equal null. turn, distance. No, not distance. Direction. Object. No. Float. Direction. Direction equal direction. Target position. Turn. Check if it didn't move. I did not wait point to. While direction. They don't have the while. Oh no, they have the while. Oh, direction. And start direction. Direction. If start equal end. Okay, if they are equal, we will go here. Recheck if target did not move. Wait. And then fire 2. And then we need to wait 2 seconds. The hell are you doing? Target. Okay. Start direction. 93. Turn. Wait. So he's targeting this. And direction -6. We're turning to the start direction. And now he will turn a lot. I will use just while I will not able to check and then. That's a really strange logic to make. Start direction, return, wait, check end direction. If they don't the same, we again should go here. That's a problem. It will not go here. The second burst is too much. Okay. Seems working as intended. Yeah. Shadow. Follow a bot as if you were its shadow. F1. You must follow the target bot with the explosive device, but without touching it. Otherwise, it will blow up. Every time the target bot stops, you must be close to it, less than 10 meters. After you manage to stay close to the target bot at 10 successive stops, it will lead you to the finish pad and the exercise is over. At every stop, the target bot checks that you are there. If you are not there, you must start over again. General principle, repeat forever. Look for the target bot, calculate the distance to the bot. If the distance to the target bot is less than 5 meters, move backwards. Otherwise, calculate the direction of the target bot and move towards it. As many times before, use while true in order to perform the infinite loop. Look for target bot with instruction radar. You don't have to test if the radar found a target bot. There must be one. Use the instruction distance to calculate the distance between 2 points. The first point will be position of your own bot, given by position. Second, the position of target, given by target position. Okay, then. If the distance to the target is smaller than 5, move backwards with a speed inversely proportional to the distance. Again, with motors. The closer you are to the bot, the faster you must move backwards. You can use the expression distance 5 minus 1 in order to achieve this together with the if to say if the target is closer than 5 meters. If the distance to the target is greater, move towards the target. First, calculate the angle necessary to face the target. Okay, so we are applying the previous thing. And there is actually an answer to the previous selection direction. You can then adjust the speed of the right hand, left hand motors in order to follow the target. We know this part. The only task left for you now is to declare the variables. No. Okay. Failure. You are too far away. Start again 10 times. Object. Target. Radar. Target. Bot. So, while true will make, or I prefer target not equal null, because I think it will explode at the end. 5 meters. Integer distance min 5. Okay. So if len, we need to find len first. It will be int len equal nothing for now. Len will be distance between our position and target position. If this length is less than 5, less than minimum distance. No magic numbers, please. We will use motor like this. Len by 5 minus y. Len by minimum distance minus 1. So this will be power. It will be float power. And motor will get this power. Power left, power right. Interesting. Can I do like that? They allow that. Apparently yes. So basically I assign this to both of them in one line. Next, look, calculate the distance, move forward, move backwards, otherwise calculate the direction of the target bot and move towards it. And this should be, okay, this I think makes it negative. Okay. Otherwise we will continue. Well, make while loop. If else will motor forward, but we need to know direction to the target position. And we need a float direction. If direction less than 0, we will make power equal 1/90. In this case, it's a left turn. No, right turn. Okay. They're confusing me with this plus minus. Should I even use this here? Okay, let's make like that. Should work. Why are you so close to it? He's getting too close. I think I need to make if else. Because I made a continue, I think it doesn't check correctly. They should add check from minimum distance of 5. Let's go home. I thought he will just go, yes, right in on me. Else we should go here. I think it will do the same. If continue was working actually. Stop. Compile, okay. Hello. Why are you trying to ram it? Maybe the formula for the deceleration is wrong. Huh. Why are you actually going so close to it? Oh. Go away, go away. Whew. We made it. Oh, now we are moving to the mover. But let me see their solution. What's happening here? Motor 0, brake, okay. Less than 5. Motor len -1. Walk backwards, else direction. 1 plus steer by 90. It's the same. You will not see it, but I got a notepad here to compare. So target. I'm interested in this part. Land distance, position, target position. Land less than 5. Okay, motor. I'll go land distance -1. Else direction, target position if it's less. Right motor goes with this. Left goes with this. Basically the same. Let me see how it behaves with their program. I can't. Okay, let me copy. For some reason I can't run the example. Yeah, he does the same thing. He comes too close, then backs up. Exactly the same behavior. Wrong headphones. Okay, they're going. Well done. Okay. Mover, retrieve a titanium cube. Press F1. Okay. Move the titanium cube on the finishing pad. You do not know the position of the titanium, but we can tell you the position of the finishing pad, x10 and y-60. Why I can't use radar? In order to solve this problem easily, we will use a new way to move the bot with the instruction go to. With this instruction, you can very easily reach every position if you know the exact location in the form of its x and y coordinates. The bot will turn toward the goal, move forward, and even turn around any obstacle. If we summarize, the following are the different way to move a bot. Motor, left, right, allows a direct, precise control of the two motors and allow you to stay in control of the motors at every fraction of a second. Move distance and turn angle. Use these instructions in order to move forward of a certain distance or to perform a rotation of a certain angle. All parameters are relative to the current position of the bot. Go to position allow you to reach easily a given absolute position. So it will go around obstacles. But is this counting water? Use the instruction radar titanium in order to find the titanium cube. Then test if a titanium cube has actually been found. In this exercise, this line is not very useful because we know that there is a titanium cube somewhere. However, it's better to take the habit of testing whatever your radar returns. Yes, error checking is important part of the coding. Okay, the variable item is of type object. In order to know the exact location of the object described by the variable, just write item position. In order to take the titanium cube, use the instruction grab without any parameter. In order to drop, use drop without any parameter. We know the coordinates of the finishing pad. You must declare a variable of the type point. And fill the right coordinates. Then you can give the variable the parameter to the instruction go to. Remark, you don't have to take care of the z coordinate in the case of a bot that cannot fly. Okay. So object or radar titanium or object pad. Can I find the finish pad? Or I have to use coordinates. Keys. Robots, aliens, misc. No. Okay, so point pad chords. It's a new point. 10 minus 60. Okay, 10 minus 16. Unknown function. How do I create points here? I forgot. Wait a minute, it's type. It's a type, that's a problem. So I can declare like that, just. So if I go to or position, position, then I will grab, and then I will go to add chords. Unknown object. It's not a cube. Just a titanium, yeah. Item, let it be item. There is a cube and there is a pad. Retrieve several titanium cubes. So, radar all. This exercise is very similar to the previous one. There are now 3 titanium cubes that you must move to 3 finishing pad. Here are coordinates of the finishing pads. Repeat 3 times. Look for the most distant. Then pick it up with a grab, go to one of the pads and go to drop the titanium. If you look for the nearest titanium cube, the radar would find one that you already retrieved and dropped on a pad. Therefore, you must look for the most distant. I can just circle like minimum radius where I will not find search. Use for loop in order to repeat 3 times all the instruction necessary to retrieve the titanium cube. Find the loop in order to find the most distant cube. Use the radar. So all around, but a minimum. -1 means the furthest filter. Min max. Then why do I need min max? Filter. No, it's a sense. Default is 1. The value 1 returns the closest. -1, the furthest. Okay. The variable metal is type of object. Coordinates. X10. Y coordinates 60, 70 by 5. So, arrays time. Point. Pads array. So 10 minus 60. 65 and 70. 60, 65, 70. Is this correct? No, wrong type of assignment. I again forgot how to make a race here. So I need type apparently point. Yep. Nope. Non-function. Variable not declared. Wrong time assignment. Wait a minute. Can I create an array like that? Yeah, finally. So object cubes radar all. Okay, like that. Titanium. And then for integer I equal 0. Can I make like that? Integer count equal 3. Is this allowed like that? So then go to cubes E position, grab, then go to pad E, and we got a point there already. And this should be fine. Should traverse all the arrays properly and get everything fine. Whoop. I forgot one small problem. Drop. One small command. And go back. Mover. Move. Okay. And voila. Well done. Mission accomplished. Convert some titanium ore to cubes. Okay. Convert some titanium ore to titanium cubes and drop 2 titanium cubes on the pads. The coordinates like that. Direct extract titanium ore from the subsoil. You just have to pick it up. Converter converts titanium ore to titanium cube. Just drop the titanium ore on the platform, move backwards, and wait until it has been converted. I repeat 2 times. Wait until there is some titanium, go to the titanium ore, pick it up, go to converter, drop, move back 2.5 meters, wait until it's done, pick up the titanium cube, go to the platform, drop the titanium cube. Okay, for loop allows you to repeat 2 times all the instructions. The titanium ore is not available immediately. You will have to wait until the derrick extracts it. Use a do loop as follow. After the loop, when the raider has found 1 titanium ore, you can go to its location, object position, with the instruction go to use instruction grab to grab the titanium ore. Use the following instruction in order to find the converter. Object radar converter. Okay, after you drop the ore on the converter, move back 2.5 meters with move. A second loop allows you to wait until the titanium cube is available. You must limit the range of the radar to 5 meters, otherwise you will immediately find the titanium cube that already dropped on a bed. The x coordinates are 10 of 2 pads. Okay, the y 6560. La la la. Okay. So they do it like that. For me, it's easier to create array. Point pads array to integer count. We got 2. So let's go like that. New point 10 minus 60 and new point minus 65. Yep. Semicolon. Okay. Next. For integer e equals 0 while e less than count e plus equal 1, we will get while we need here some objects or and object converter. This we can find immediately. And object item. So while or reader titanium or equal null, we will wait a second. If we got one, we go to this OR position. Then we grab this OR Then we go to converter position, drop and move 2.5 meters back. Then while, and here we get some additional parameters. Item equal reader titanium angle 0 focus 45 we can make min 0 max 10 make while it's equal null we are waiting. Okay, wait a second. I think I can wait a free because there is a cycle of converter. Converter. 15 seconds of duration. Oh my. So I can wait for 15 seconds. And for Derek. There it is. 10 seconds. So we can wait at least this. It will not be faster. Again, it's a magic number. Usually if it's a constant, you will make like a const here. But there is no const. So we can make this Derek cycle equal 10. So it's a cycle in seconds. And same for the converter cycle. It's 15 seconds. This also can be a constant, but okay. So we will go to the item position, grab it, and then we will go to pads I position and drop it there. Should work. Okay. Voila. Done. Not so hard. Flying mover. Move a titanium cube across obstacles. Interesting. I hope I will make it fast. I will finish here today. So move the titanium cube on the finishing pad. You do not know the position of the titanium. We can tell you position of finishing pad. The winged bot can get across obstacles. The instruction go to if performed on winged bot will automatically perform a flying move. Take off at the beginning and landing at the end. The instruction can actually receive a second parameter, which is not compulsory. The flying altitude. If no second parameter is given, the flying altitude will be set to the default value of 10 meters. Altitude from the sea level or the ground level they count. Use the instruction radar titanium in order to find the titanium cubes and test if a titanium cubes has actually been found. It's not very useful. Okay, it's as usual. A variable item object type. Position, grab, drop. Okay. So basically the same object. Our cube radar titanium. It's cube, not ore. Yeah, titanium. Then object, no point pad will be 10 minus 60. Yep. That's all we need to do. Grab and then go to pad and drop. We need to drop. Yeah, drop. So that's easy. It's actually too easy. Well done, mission accomplished. I didn't even land it and didn't even drop it. Okay, it was too quick. Can have like 15 minutes more. Okay, functions, finally. Create a function in order to make your program shorter. It's not how it works, but okay. Especially if you will make a function and not reuse it. The bot must pass over all the blue crosses on the ground. The way that must be covered is made of two squares. The first one measures 15 meters, the second 25 meters. General principle. In order to solve the problem, the most efficient solution consists in creating a function that instructs the bot to move on a square shape of a certain size. The main program becomes then very simple. Square 15, square 25. We still to define the function called square. In order to do this, you will have to write some instruction outside of the block. That until now was the frame of each one of your programs. At the very end of the program, After last closing brace, we will define the function square. The program will take the following shape. Why do I need to attach it to the object? Let us look in the details. Void means that function will return no value. Object, when you write this in front of the function name, you can have access in the function to all the characteristic of the bot. So basically it's a member of a class. So you get this and all of its members and fields. Such as position, orientation, etc. This exercise, this element is not compulsory, as we will not need the characteristic of the bot in the function. Square, this is the name of the function. You can call it square or many other names. Okay, it's the name of the function and its params, arguments. Here defines the parameters that the function will get when it's called. The first time the function is actually called with square 15, the variable length will contain the value 15. Second time 25. Here's the detail. What will happen when the program is executed? This part made a French person because it's a freaking French with accents and the French words. And as far as I know, French don't use French in coding. They still use English because compilers don't understand French. So the main function will be executed. The line square 15 the program will follow the red arrow and enter the function square the first time. Length contains 15. At the end of the function square, the program will follow orange arrow and comes back to the main function. At line square 25, the program will follow blue arrow and enter the function square a second time. At the end of the function square, the program follows the light blue arrow and come back to the main function. But actually it's the same place in the memory. The function square uses the instruction move and turn. In order to make it shorter, you can use a for loop that will repeat the instructions move and turn 4 times. However, it's not compulsory. So this is a function. And I can't copy. Are you serious? Can I grab this? Why not? What's the point of the exercise? Just do I need to create this function myself, or I can use your function? So they basically there are 4 corners. First they go 15 meters, then turn left, then again move 15 meters, turn left, move 15, turn left, go here and turn left. So 4 times 1, 2, 3, 4. Then 25 does the same thing. So this function is nothing new. And voila, we did it. Nothing interesting. Create a procedure in order to teach your bot to perform spiral. Oh, interesting. So we will slowly reducing the length. Follow the way in form of a spiral. The bot must move 2 times 25 meters forward and turn, then move 2 times 20 meters and turn, and so on. So one function is move length, turn 90. Move length, turn 90. So this... Why I can't copy this to here? Okay, apparently the objective is to just make people write the freaking function. Move int, then distance. It's a keyword. Why it's float if distance it's always integer? Okay, for integer e equal 2 while e greater than 0 and e minus equal 1, we will move distance and turn 90. For now it's hard-coded. So now you just need to write the main function. Repeat the instruction inside the block as long as rest is greater than 0. Yeah, they also decided to use while loop. I thought about for with a step of 5, but they decided while. While rest more than 0. So float distance equal 25. Then float step is 5. So 4 nothing until distance is greater than 0 and distance minus equal step. And like that we should call part with a distance and everything should be fine. What fun. Why there is a colon? That's a typo. It's this symbol of a tab glitch. Will we work? Each part contains of 2 moves. Then hop, 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 hop. Voila. Remote control, last one. Okay, can I make it quick? Remote controller robot using an information exchange post, so it will pass over 6 blue waypoint. Okay, let's see. So this is the bot. This one does... okay. Control. Interesting. They got one exchange post only. Let's go. Remote control robot using information exchange post. Okay. We'll grab it. Robot without any energy cell. This is master you have to program. Grabber. Okay. Information exchange post that receives information from the master and transmits it to the slave. Practice bot which waits for order from the exchange post. This robot has already been programmed. Information exchange post source name value couples. The control the slave robot we use couples. Why it's in English and this is in French? Nom and valeur. Parameter for the operation in English. Okay. Order number 1 means move and order 2 means turn. The parameter is the distance to move or the turning angle. For example, to make the slave move 20, send order 1 under move param 20 value. Okay, so we need to pass like array of commands to it. The instruction send following 2 pieces of information. Order 1 param 20. Slave robot waits for an order and executes it. Once the order has been executed by the slave, it removes the order from the exchange post. Once an order has been sent, the master must wait for the slave finishing the order. So we need to wait until there is some command on the post. When slave deletes, we send new. Oh my fun. Has been sent master. This is done by testing if the order is still inside the exchange post. Just write test info order. As we must give more than one order, the most convenient to write a function send to post that sends this order and waits for its completion. Okay. To move forward by 20 meters, you must write in the main program. Order param. Let me write this part. No. Wait a minute. It should return bool. No. Return from the function is answer. There's no error checking on anything. And to post. So it should have string. No. They both numbers. So they use both float and float. Float order. Float param. Send order send param this. Yeah, param and order. Why they send it in such order? So when I send order, it will transmit it immediately. So if I will send order first, it will not get a param until while test info. Wait a second. Order test info order 100. So 100 it's also so this part is okay. Now we need send to post 120, then turn. Now where is the commands? I see it for the move. Second is turn and the angle. Okay. So we need to send to post. Object. Can I make it object? Okay, that will be later with the classes apparently. Because you can create class of param and order and create array of these classes and send in the for loop and not like make us how many 1 2 3 4 5 6 7 8 9 commands. Yep. 1 2 3 4 5 move. 1 2 3 4 turns. So first we sending order 1 25. Yep. 20 10 10 10. So 20 10 10 10, and between each of them we are sending command 2 with 90 to the left, say alt, left, and last one to the right. So like that, and like that. Okay, are we good? Test doesn't work. While wait. Param order. What? Test info. What we got here? Param 25, order 1. But where is the turn? So we restart only for this. No power cell. Okay. So 125, 91, 21, 21, 21. It sends param here. It moves. We are waiting. It's trying to move too far. Oh, sorry. Did I mess up the length? What? 25. Oh, 20, 20. That's a problem. Okay, that's better. So the next time we will look at the remote control of the classes. And this will be all for today, for this week, so I will see you all on the next week. It was interesting part of the game. And finally they told something. So basically this must be before mission, this button, because it's counterintuitive that you first need to make exercise from here, then go to the missions. But okay. So, can I click something here? Nope, not interactive. Too bad. So, again, I will see you all on the next week. You can find this game here if you want to play yourself. It's now open source and free. And I will see you all on the next week. Have a good rest of your day. Have a good rest of your evening. Have a good weekend. Bye-bye.